can see here, the paths to intelligent visibility layer. So Israel pretty much gave the start and the introduction on the DDoS. The question is how everything come together into a visibility to mitigate these threats. So we'll start with some of the basics for visibility when it comes to security, which is the single inline bypass on the left-hand side and a multiple inline bypass on the right-hand side. Typically, when there is an inline device such as either DDoS, firewall, DLP, they are connected inline to this device, which is an inline switch. In this case, it's a Niagara. At this device, it's a network packet broker and also a bypass. As you can see on the left-hand side, traffic is going between N1 and N2, and from N1 it goes to A1, which is basically the appliance port into the DDoS, and then to the N2. During this process, the Niagara device generates some heartbeat to verify that this device, the security device, is actually, or the appliance is up and running. And if it's not, we do that by checking it via sending heartbeat packets between the network ports. That's very traditional, runs in many, many networks. As you can see on the left-hand side, this is a single inline appliance. On the right-hand side, this is a multiple appliances. For example, there is an option to run multiple DDoS, doing load balance and filtering, so be able to utilize and scale as the network grows. So with that said, I would like to move forward a little bit and share what is really unique with L7Defense, Layer 7 Defense, and Niagara Networks. So Niagara Networks initiated the open architecture, which is basically combining packet broker functionality with an application layer agility. As you can see on the right-hand side, this is a multi-purpose device that has a capacity to do a network packet broker, i.e. receive traffic from the network, sending it to some monitoring device, a bypass as well, sending it to security device. And also what we added is what we call it the open architecture, or the Packetron, where L7 Defense with their DDoS mitigation resides. This allows basically the capability to receive the traffic as it comes to the Niagara, forward it to the DDoS mitigation, and make sure there are no threats within the network. As you can see in this slide, this is really a whole solution that includes the Niagara Network SSL decryption engine, the network packet broker, that basically kind of the traffic grooming within the network and sending all the traffic that's necessary to be mitigated to L7 Defense. All this it's built in. Some of the key benefits, obviously, is mitigation in real time. So traffic that actually arrives from the network, which is either via north-south or east-west via a virtual, can be decrypted, send it out to be processed to inspection, and re-encrypted if needed back to the network. Allows also a low traffic footprint detection, which is unique to L7 Defense. The SSL is basically a pre-inspection process when traffic arrived into the Niagara, a multi-purpose device, be able to decrypt the traffic and then send it to inspection and repass it and re-encrypt it. Another unique feature here is the ability basically to do offloading. So traffic that actually, only traffic that's need to go for inspection with L7 Defense will basically go there. Supporting all network speed and rates from 1 gig all the way to 100 gig in that specific platform. And all this can be managed via a central configuration management platform running SDN, which I have a couple of slides I would like to share. So essentially, this is how the solution typically will be deployed. and can extend to multi-sites or large or few data center. So the Packetron open architecture, what it allows basically to prospect and customers is, this is an example of using the DDoS for mitigation. But since it's an open architecture, as you can see on the above the device itself, these are applications that potentially customer can install on the Packetron. We are focusing right now with obviously with L7Defense for DDoS mitigation, but since it's virtualized, this Packetron can host some other application for threat detection, some troubleshooting tools, application monitoring, and some analytics and so forth. As long as it's basically running on a VM, that can be deployed as well. As you can see, under the SSL decryption, URL filtering, these are a capacity that the Packetron has as built-in, i.e. from Niagara Networks. So we can be able to decrypt the traffic, send it to all the appliances for inspection, and if you need to do some more advanced features such as URL filtering or load balance to multiple appliances, and that can be done as well. I would like to share one deployment scenario. It's a little bit involved. There are 4 sites. These sites are data center. Each one of them has different version, basically, of applications. Some of them running the in-house, and some of them running obviously some other applications. So as you can see, they're all connected via the NVC, which is on the right-hand side. This is the Niagara visibility controller. The NVC communicates to all the devices via OpenFlow, so it's an SDN controller, and be able to manage all of them together. So essentially, as you can see here on data center D, where we have the mitigation system, from a customer perspective, it's very easy basically to go, let's say, to DCA or DCB, drag a specific traffic, which could be based on layer 2, layer 3, layer 4, or above, and drag it for inspection. Most of the work done behind the scene utilizing OpenFlow and REST API, so customers are pretty much not exposed to how this scheme is working behind the scene. But the idea is to have a very easy way to groom the traffic from multiple sites to the right application for threat mitigation, and for example, in this case with L7Defense for DDoS attacks. So a very cost-effective way to use in a multi-site management system. It does the system also auto-discovery all the topology. So if there are 4, 5, or maybe 20 of the devices, this is all going to be auto-discovery via the topology. Each one of the sites traffic can be groomed and sent to either a central site or maybe to locally be inspected. Very easy to deploy in a matter of minutes. It doesn't involve really a lot of hard preparation, since there is auto discovery. All the connectivity between the devices are done behind the scenes, so it's a very much a plug-and-play approach. And in addition, customer can obviously update the system, the images, store configuration, and so forth. So as you can see, the idea is not only to provide security with L7, but the idea is how we can secure the network, getting the right traffic to be analyzed and inspected by L7 for DDoS via a large-scale network.